Welcome back to the channel. Today we're going to look at a differential equation. This was actually requested by someone in the comments, so leave comments, let me know what kind of videos that you want. Someone wanted to learn a little bit about differential equations, so I selected one. This is one that is in the IB higher level, and not a brutal question, but honestly, if you don't know differential equations, then it's a great place to begin. You don't need any background on this. You have to know a little bit about derivatives. You should know the product rule. We're just going to think backwards, so let's take a look at it. So this one is essentially asking us, this is actually the equation. I'm just going to put a box around it. And if we look at the parts of this equation, you can see on one side you've got cos x, you've got tan over here, you've got an exponential, but more importantly, you've got a y and a dy dx. And so the objective here is to figure out what y is in terms of only x. So I could try to sort of isolate y right now, but that wouldn't be exclusively in terms of x. I'd end up having a differential dy dx. So what I'd like to do is sort of work backwards and see if I can remove the dy dx. And again, what does that make you think about? Well, integration, right? So if we want to undo or invert back, then we're going to probably end up with an integration. Okay, so let's take a look here. What you want to do is sort of take notice of any patterns. There's some standard patterns. So for instance, take a look at this one. If I said dy dx, say plus y, and I'm going to put something in here on purpose. I'm going to put an x squared here, and here I'm going to put a 2x. And let's just say this is equal to, oh, it doesn't matter, I'll say e to the x. It's fun to put in different kind of functions. So here you'll notice something, that on the left-hand side, that y, when it's differentiated, gives me dy dx. And not only that, but when I take the derivative of x squared, I get 2x. So there's a particular pattern here. Do you see? That's actually the derivative of a product. So in fact, it's the derivative, d by dx means the derivative of y times x squared. So we try to look for these patterns, and you get used to this after a while, and your eye gets better at it. Typically, you're going to take the y, and then you're going to take the other function over here. And then you could just say that's equal to e to the x. And well, this is really good because look, I don't really have a dy dx. I've got this d by dx, but I could sort of invert that. I could isolate the y by undoing d by dx, which is integrating with respect to x. And this is a balancing act. This is an equation. So what I do to one side, I do to the other. And you can see here now I'm able to isolate y. So y x squared equals the integral of e to the x. Well, that's just e to the x, and I'll put in a constant of integration. And now I can actually isolate y. So we want to try to use that sort of idea. Okay, now let's look at our problem. Well, first off, you can see that the derivative of y is dy dx. Great. But if I look at this term and I take the derivative of it, I don't get that. So I can't use this property right off of the bat. So there's a couple of things I can do. Number one, I can clean the dy dx. So start fresh with just a dy dx. So what I'm going to choose to do is multiply through by e to the 3x. And that's going to give me dy dx plus, that's going to leave the y times tan x equals cosine e to the 3x. Okay, now always check it, see if it works, and it won't here, but the derivative of y is dy dx. And then I guess 1 is our function here. The derivative of 1 is not tan x. So what I'm going to do is I'm going to get clever here. I'm going to use my intuition. I'm going to multiply through by some term, because maybe I can build this so that it will be the derivative of a product. So I'm going to multiply through by some factor. It's called the integrating factor, who cares? So I'm just going to multiply it through. And now I'm going to reassess this. So I know that the derivative of y is dy dx. What I'd really like is that the derivative of I equal to I times tan x. Okay? So the derivative of I, if it gave me this, then I would have the derivative of a product. So what I'm saying there is, what I'd like is a function, or a term, an integrating term, that when I differentiate, it gives me ix times tan x. Well, why is that useful? Well, notice something here. If I take I of x and I divide it on both sides, then I end up isolating the integrating factor exclusively on this side. Not only do I do that, but I notice that this is a special pattern. If you have a function and in the numerator you have the derivative of it, you know the integral is the ln of it. So in other words, if I was to, let me come on over here, if I was to integrate I prime by I dx, well, that's equal to the ln of ix. Well, that's useful because then, do you see, now I've completely isolated I. So, and again, don't forget you have to do that to both sides. So what I'm going to do is set that equal to the integral of tan x dx. So on this side here, I'd like to know the integral of tan x. If you don't know it, you could use a u substitution. So I could integrate tan x, which is sine x, over cos x dx. You could let u be cos. So u equal cos x. So du is equal to negative sine x dx, or a negative here. And what you're going to find is when you do that substitution, that's just simply equal to the ln of 1 over cos x. So a little bit of work and you'll get 1 over cos x all lned. So on this side here, I'm going to say the ln of 1 over cos x. Well, that's interesting because you can see now that the integrating factor is just 1 over cos x. So I of x, what this implies, is equal to 1 over cos x. So I basically just solved for the integrating factor. And that's going to do some magic because that's going to produce, I've just created a factor that when I plug it into the left-hand side makes this the derivative of a product. So now what I'm going to do is multiply through by 1 over cos. So I'm going to get 1 over cos x dy by dx plus y. Now here I'm going to break tan down into sine in the top with a cos in the denominator multiplied by cos. That incorporates the integrating factor. Equals, well, notice the cosine cancels and I'm just left with this. Okay, well, how does that help? Well, notice now, look, the derivative of y is dy dx, and the derivative of 1 over cos x is equal to sine over cos squared. So in other words, this whole thing on the left-hand side is nothing more than the derivative of y times 1 over cos x. And that's equal to the right-hand side, which is just e to the 3x. Well, this is kind of nice because look, if I can get rid of d by dx, I've isolated y, which was what I wanted to do in terms of just x. So how do you undo that? Well, you take the integral. So these undo each other. They're inverse operations. Don't forget your dx. So these are bookends. They have to go together. And we're balancing equations, so what I do to one side, I do to the other. So this allows me to write y times 1 over cos x equals, well, the integral of e to the 3x is a third e to the 3x. And I don't have any more integration going on here, so I have to introduce a constant of integration. And, well, we've kind of done it. Now, what I could do is just multiply through by cos x here. So this leaves us with y on the left-hand side equals 1 over 3 e to the 3x times cos x plus c times cos x. And let me just introduce an initial condition here, because often they want you to solve for the constant of integration by plugging y, 1 for y, and 0 for x. So 1 is equal to 1 over 3 e to the 0 times the cosine of 0 plus c times the cosine of 0. And e to the 0 is 1, cos of 0 is 1. So this ends up being 1 equals 1/3 plus c. So c is equal to 2/3. And so we can finally write the answer, given this initial condition, as y is equal to 1 over 3 e to the 3x cos x plus 2 over 3 cosine x. And I'll put a box around that. Don't forget to check your answer, make sure that it works out okay. I just put the constant of integration in where that is. And so what does this mean? Well, it means that this is the function y in terms of x that when differentiated and plugged into this original equation, differential equation, will make the left-hand side equal to the right-hand side. There you go. Don't forget to slap a like on this video. Don't forget to subscribe if you haven't already. Also, let me know what kind of videos you would like to see on this channel, and I'm happy to produce them for you. You want to see more differential equations, trigonometry, calculus, complex numbers, number theory, whatever works for you, let me know, and I'm happy to make those videos. Bye for now.